Okay, so first you should understand one thing, okay? So you can see that, okay, when we are finding ABCD parameter and Z parameter, the impedance parameter, okay? When we are finding ABCD parameter and Z parameter, okay, parameter, you have to, okay, so and also we have tried to find some Y parameter also, admittance parameter, okay. So this is transmission parameter, this is impedance parameter, and this is admittance parameter, okay. So when we want to find this parameter for a microwave circuit, okay, we have to sometime open circuit, keep open the circuit, okay, and sometime we have to short circuit, no, we have to keep the port open, some port we have to keep some port open, okay, and we have to also sometime keep this port as a short circuit. This port should be shorted, okay, when we are going to find ABCD parameter and Z and Y parameter, okay. Is that clear? So it is okay, no? We have seen it, okay. Now, so consider the microwave circuits, okay. I told you that, okay. I told you that we verify that sometime if you have a let's say that amplifier like this, okay, like this, okay, this amplifier, okay, this is a uh, what is called transist amplifier. This is transist amplifier, okay, transist amplifier, okay. So this is let's say that this is a microwave circuit, okay. So this is maybe working on maybe uh, 10 gigahertz, 6 gigahertz range, okay. So these are microwave range, high frequency range, okay. So sometime we have seen that, okay, when we are working in this with this very high frequency range, okay, so there are inductance and capacitance with this path also, okay. So if you consider inductance, okay, so it is so you know the impedance, that is L omega J. This is the impedance created by the inductor, okay, and you know the capacitive inductance, capacitive impedance or capacitive reactance, that is 1 over C omega T, okay. So you can see that if this omega is very high, if this L is very zero, if L is very low, near to zero, okay, but this inductance value may be a considerable value because this omega is very high, okay. And in the other hand, okay, uh, if this C is very low, but this omega is very high, okay, so this capacitive reactance can be very low, okay. So inductance reactance can be very high and capacitive reactance can be very low, okay. So if you want to keep short this circuit, okay, keep short this circuit, sometime due to this inductive effect, okay, so it is not open because there are some resistance there, impedance there, no, because of this omega, okay. So this L is maybe very low, but this omega is very high, okay. So still you have if you want to short circuit this N, if that transmission line, okay, so you are using a transmission line to end to end this end short circuit, but okay, but due to the frequency is very high, okay, if this transmission line has a inductive values, okay, so it has a considerable impedance or considerable reactance, okay. So it is not look like as a short circuit, okay. So we see it as short circuit, but logically it is not short circuit, okay. So it is some impedance is there, okay. Let's say that this impedance is very high, so it may be open circuit, okay. So although we have seen that it is short circuit, if this impedance is very high, it can be a short circuit, sorry, open circuit. Okay? The same thing happen in vice versa. Okay, so if you think port is open, okay, but sometime due to this capacitance effect, okay, the port can be seen logically, the port can be short circuit. Okay, if you although if you keep it although you have kept it as open, but maybe actually it may be short circuit. Okay, so this is happening high frequency. Okay, when we are working with high frequency, that can be happen. Okay, so you should note. Okay, okay, when we are working in high frequency, okay, with high frequency, okay, in microwave range, okay, range, it is very hard. Okay, it is to very hard to practically, okay, practically keep a circuit, open or short. Okay, open or short. Okay, so this point you should note. Okay, is it clear for you? Is this statement is okay with you? Okay, so if we are working with the high frequency, the open circuits and short circuits status are not easy. Okay, to achieve open circuit or short circuits, it is not easy. We have to very carefully calculate and do it. Okay, okay. So you should note this point. Okay, so that is why actually when you have construct a circuit for high frequency, sometimes circuit is not working. Okay, actually because of this scenario maybe. Okay, although you have think that uh, path is connected, okay, actually that path may be as open circuit. Okay, so you can't so maybe your circuit may be not working properly. Okay, so that can be happen. So this thing you should understand. Okay, so you can see that if you want to practically measure okay, if we want to practically measure Z parameter, Y parameter, or ABCD parameter for microwave circuits, okay, maybe it is very hard. Okay, or maybe impossible. Okay, or maybe impossible sometime. Okay, you will have some wrong measurement. Okay, so Z parameter, ABCD parameter are we practically, if we want to practically measure, okay, this ABCD and Z parameter for microwave circuits, it may be somewhat hard. Okay, because you can't keep or open the circuits, keep short or open the circuit as you wish. Okay, so it can be changed. Okay, so this Z parameter, ABCD parameter are sometimes practically hard to measure for microwave frequencies. Okay, so we define another matrix, that is we call scattering matrix. Scattering parameter. Okay, parameter. To measure this scattering parameter, actually you no need to open circuit or short circuit the circuit. Okay, port. You no need to open or short the port of the circuit. Okay, so you no need to do the open circuit or short circuit. The port should not be open circuit or short circuit to measure the scattering parameter. Okay, so these scattering parameters are very important for microwave uh, circuits. Okay, because we can practically measure it actually. Okay, okay, actually this instrument we called it network analyzer. Okay, we called it network analyzer. Okay, analyzer. Okay, so there are two types actually, vector network analyzer and uh, vector network analyzer and network analyzer. Okay. So using this, you can measure the scattering parameter. Okay. So we have one practical actually. Okay. So we will do it after doing this part. Okay. So you have to measure the S parameter of different uh, microwave circuits using this net uh, network analyzer. Okay, in our campus we have one. Okay, actually we have two network analyzer. One is a good one. Okay, big one. Okay, and also we have a mini network analyzer. Okay, so both from you can use both the instrument to get the S parameter measurement. Okay, so we will do it later. Okay, now we will see what are the S parameter. Okay, so this is how we define the S parameter. Okay, this is how we define this parameter matrix. Okay, so you can see that here. So as usual, here you have here the input network is uh, considered. Okay, so here also input network is considered. Okay, so number of ports are n. Okay, so any value. Okay, that is for the general case like this. Okay, so this is our circuits. Okay, so you have 1, 2, 3, 4 like this up to n port. Okay, so now we are not considering the total voltages or current. Okay, but we are considering reflected and forward voltages. Okay, reflected and forward voltages. So what we are considering here to get the S parameter measurement. Okay, so you know that. Okay, so you know that if a signal, uh, if the voltage come to this port, okay, if this impedance are not matched properly, some uh, portion of the incoming signal will be reflected. Okay, so so it create standing wave, and uh, already we find what is this. Already we have learned what is SWR and how it can happen. Those things we have learned. Okay, so basically you know that if the impedance is not matched, okay, uh, incoming the portion of the incoming wave may be reflected. Okay, due to this impedance in matching. Okay, so for this port, okay, the input or forward voltage are considered as plus voltages. Okay, and reflected voltages are considered as minus voltages. Okay, minus voltages, V1 minus like this. Okay, so this is plus direction and this is minus direction. So you have considered one direction. Okay, so if this direction is plus and this direction may be minus. Okay, so you can see that if you consider this kind of port also, the same thing is there. Okay, so you have a forward voltage to this direction, and you have uh, mark it as the plus port. Okay, this direction, and this direction it will be minus. Okay, like this. Okay, so you can mark all these voltages value. Okay, so I think it is marked here. No, there is a diagram this one. Okay, so you can see that this is V1, the forward voltage, and this is backward voltage. Okay, and this is yeah, sorry, so I have marked it wrongly. Okay, so this direction inside the port it should be plus, and uh, out of the port it should be minus. Okay, so output of out means that is reflected. No, okay, so here I have marked it wrongly. Okay, so here it consider. Okay, it is not, so actually this here we can't consider direction. Okay. So if we have this kind of port, okay, if we have this kind of port, okay, so this is our network, okay. So this input we mark as plus, and the reflected we mark as minus. Input we mark as plus, reflected we mark as minus, okay. So this is third port, the input is V3 plus, and output will be V2 plus, okay. So okay, so you can write the voltage and current like this, okay. So here first we write the reflected voltage matrix, okay, and here we write the forward voltage matrix, okay. So if you have n port, okay, if you have n port, there should be n number of reflected voltage, okay, reflected voltage, and this also there should be n number of forward voltage, no, there should be n number of forward voltage, okay, there should be n number of forward voltage, okay, forward voltage, okay. So if you consider, okay, so so you can see that here it is a column matrix and there are n rows, okay, there are n rows, okay, and for this one also there should be n rows, okay, there should be n rows, okay, and here also there should be n rows, okay, and uh, for matrix multiplication, for the second matrix, the number of rows should be equal to the number of columns, okay, so there are also n columns, okay. So this matrix will be n by n column, okay, that means n is square, okay. So you will have n square, number of n square is parameter, okay, parameter, okay, okay. So we will see, so I think you got the idea, okay, so I will explain it again, okay. So what you should know is, okay, so I will write it here again. So if you consider n-port network, okay, so if you consider n-port network like this, okay, okay, let's say that this is port 1, so input voltage is V1 and the reflected voltage is V2, this direction, okay. So if this is in port 2, input voltage is V2 and reflected voltage is V minus, okay. So here also same, V3 plus input voltage and output voltage V3 minus, okay. So for this port, okay. So if you consider n port, there should be n number of reflected voltage, okay. So you have to first write the reflected voltage, V2 minus, V3 minus, so on up to Vn minus, okay. So this is a column matrix, okay. And it should be equal to, you have this parameter matrix, okay, and you have the forward voltage matrix, okay, this V2, okay, V2, V1, V2, sorry, this is V1 plus, okay, V1 plus, V2 plus like this, okay, so V1 plus, V2 plus, V3 plus, so on up to N, Vn plus, V capital N plus, okay. So there should be n rows, okay, so you should have, so you should have S parameter, okay, and it should have n rows, okay. So this should have n rows. This is second row, third row. It should have n rows, okay. And so you know that here also you have n rows, okay. And this column for the matrix multiplication, this the first matrix column should be equal to other second matrix rows, okay, otherwise you can't do the multiplication. So here you should have n columns also. This is the second column. This is the first row, third column, so on. You will have first row n column. So this is n row n column like this. Okay. So you will have number of S parameter here and n number of n S parameter here and n number of S parameter in this way. Okay. So totally you will have n square S parameter. Okay. So this is the S parameter, the number of S parameter. Okay. Same, no? Same as A, B, C, D and Z and Y parameter. Okay. Okay. Now, yeah. So, and another thing is these S parameters are very important. These are very important for microwave circuits, microwave range circuits, microwave range frequency, because the S parameter can practically measure using network analyzer, vector network analyzer, or scalar network analyzer easily. Okay. But if you want to find A, B, C, D, Z or Y parameter, other parameter, okay, it is not easy. It is not easy because you need to short or open circuit the port, keep short circuit or open circuit some ports when you are measuring. Okay. So it is hard. Okay. So this thing you should understand. Okay. Now we will take example. Okay. Let's see. Example. Let's take example from the book. Okay. I think it will be easy. Okay. So there should be some example. Okay. So we will take this kind of example. Okay. Okay. So we will see it. Okay. So let's take this kind of one. Okay. Let's say this is R1. Okay. No, Z1. Okay. Let's say this is Z1. Let's say this is Z2. And let's say this is Z3. Okay. So you have this kind of circuit. Okay. This kind of circuit you have. Okay. Now let's say that, okay. So this can be any circuit. Okay. This is a microwave circuit. Okay. 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 So let's say that this is port 1 and this is port 2. Okay. So this can be input port or this can be output port, anything. Okay. Okay. So let's say that you are going to, so you connect these circuits to another circuit. Okay. To another circuits. Okay. And the impedance of this line is Z0. Okay. So you connect this circuit to a Z0 impedance line. Okay. So this Z0 is the characteristic impedance. Okay. Because we have to consider now this characteristic impedance. Can anyone tell why? Can anyone tell why we need to consider this characteristic impedance, the input characteristic impedance, the input line characteristic impedance? Can anyone tell? Yeah, here we are considering forward and reflected voltage, no? So why signals are reflecting? Due to this impedance imaging. Okay, due to this impedance unmatching. Okay. So if this Z naught is matched with the input impedance of this circuit here, okay, so some signal will be reflected. Okay. And here the same. Okay. So when the signal is coming out, okay, and here also you are connecting to Z naught. Let's say that you are connecting to Z naught transmission line. Okay. So again, this impedance is not equal to this one. Again, the signal can be reflected here. Okay. Here also you are sending a signal, and if the impedance are not matching, the signal can be reflected. Okay. So due to that scenario, okay, we have to consider this transmission line impedance also, because this when we are evaluate this reflected voltage and forward voltage, we have to consider this transmission line characteristic impedance also. Correct? If you have any question, you can ask. Okay. If you have any question, you can ask. Okay. Okay. Now, okay, now let's mark some voltage. Okay. So let's say that the input voltage here is V1 plus, and the reflected voltage here is V1 minus. Okay. And here also input voltage is V2 plus, reflected voltage is also V2 minus. Okay. So input and reflected voltage are, uh, we have marked the input and output voltages. Okay. Now you can, so this you can see that here you have two ports. Okay. You have two ports. Okay. So you should have two reflected voltages. Okay. So this is the reflected voltages column matrix. Okay. And there should be the S matrix. Okay. And if it has two, it should have two rows also. Okay. And here also you should have two forward voltages. Okay. Two forward voltages. Okay. So here two voltages are there, two values are there. So it has two columns, two rows. Okay. So here also for this matrix also you should have two columns. Okay. So you have 2 by 2 matrix here. Okay. So this is first row, first column. This is first row, second column. This is second row, first column, second row, second column. Okay. So this is the S matrix for this two-port network. Okay. So this is the S matrix for two-port network. Correct? Okay. Okay. Now you need to write the equation. Okay. So you need to write the equation. Okay. So using this matrix, you can write the equation. Okay. So how you can write the equation? V1. So first you can consider this row. This row. Okay. So V1 minus is equal to S11 V1 plus S12 V2 plus S11 V1 plus S12 V2 plus. In the same manner, you can write the second equation, that is V2 minus is equal to S21 V1 plus S21 V1 plus S22 V2 plus S22 V2 plus. Okay. So these are the equations. Now you want to find this S1. Okay. You want to find this S11. Okay. Now you can't say that this S12 is 0. Okay. So anyway, you have to get rid of these terms, no, to measure the S1. Okay. So you have to get rid of these terms. Okay. Then what happened? Then what happened? That means what? So you have to get rid of these terms, no? So you have to make what? 0. So you need to take V2 plus is equal to 0. Okay. Now tell me what we should do. What we should do to make V2 plus 0. Tell me. Okay. So give me some answer. Okay. So think, get 5 minutes and think. Okay. Uh, okay, anyway. So what so you have to do this V2 plus 0. Okay. Now check here. Okay. Now check here. Okay. So you can see that V2 plus. Okay. So here. Okay. So try to understand this very well. Okay. So here V2 plus we have marked in this direction. No. Inside the port. Inside the port 2. So that is our standard. Okay. So you have to mark the plus voltage, forward voltage inside the port. Okay, inside the port. Okay. So that is you should understand. Okay. Now this V2 is inside. Okay, this V2 is inside the port. Okay. This V2 is inside to the port. Okay. Now let's say that you are giving a signal here. Okay. So you are giving a signal in this direction. Okay. So maybe you at first you maybe get confused. Okay. But try to keep remember this. Okay. If you can't completely understand this, at least try to remember this. Okay. So let's say that you are giving a signal in this side. Okay. You are giving a signal in this side. Okay. Now, if you are give a signal in this side, okay. So you can see that this signal is going this way and have some processing and come to this way, and it it is output from this end. No, it is output. Okay. So let's say that this is the amplifier or something. Okay. So you have a signal to amplifier. You have a signal to the amplifier. Okay. Then amplified signal will be out. Okay. So this amplified signal, let's say that you are going to send it to a filter. Okay. So you have to connect this to the filter through a transmission line to another cable. Okay. It's a cable. Okay. Okay. So now you can see that now you are inputting a signal here. Okay. Now signal is output here. Okay. So this is the transistor line. This is the transistor line. And this is the transmission line, output line. Okay. So if this is not matched, some signal will be reflected here inside the port. Okay. Okay. So it is a reflected signal. Actually, reflected signal happen if the signal is given this direction. So this inside the port will be a reflected signal. No, it is a reflected signal. Can you understand that? Okay. I will tell it again. Okay, I will tell it again. Try to understand this. Okay. Now let's say that you have amplifier, transistor amplifier. Okay. Now you have a transistor amplifier like this. Okay. This kind of transistor amplifier you have. Okay. Like this. Okay. Like this. Okay. Now let's say that this transmission amplifier should be connected to a filter. Maybe a low pass or high pass filter like this. Okay. So you have to connect it to a filter like this. Okay. Now you are given a signal, any signal here. Okay. Now you have output signal here. Okay. Now you connect this output signal to this one. Okay. This filter output. Okay. Okay. So this signal should be going inside the filter, no? That is clear, no? This signal should be going inside the filter, okay? But if this impedance, the impedance at this point, let's say that is Z1, and impedance at this point, let's say that it is Z2. If this Z1 and Z2 are not matched, okay? If these are real impedance, they should be equal, okay? Some signal will be reflected again inside the amplifier, no? Okay. Now reflected signal is in this direction. Okay. Okay. That reflected signal is the input to the amplifier, no? This reflected signal, okay. This reflected signal is input to the amplifier. Okay. Correct. Then මේ amplifier එකෙන් ඔයා දෙනවා signal එකක්, amplified signal එක එළියට එනවා. හරි. ඊට පස්සේ amplified signal එක ඔයා filter එකකට දානවා. filter එකට දානකොට මේ මෙතන මෙයාගේ මේ amplifier එකේ output impedance එකයි මේ filter එකේ input impedance එකයි සමාන නැත්නම් signal එකෙන් කැලලක් reflect වෙනවා. ඒ reflect වෙන එක තමයි මෙයාගේ input එක නේ. port 2 එකේ input එක. දැන් හිතන්න මෙයා port 1, think that this is port 1 and port 2. Okay. So port 2 input signal is the reflected signal, no? It is not a given signal, but reflected signal. Okay. So that is what you understand. Okay. So here, this V2 plus is nothing but, okay, if you are giving a signal in this direction, some signal is coming out and some signal should be reflected here again. Okay. So that reflected signal is V2. Okay. Now don't confuse. Okay. Here plus value. Why this plus? That is considering this port. Okay. දැන් මේ port එක මේවා කරලා තමයි මෙතන මේ plus කියලා දාලා තියෙන්නේ. port එකට ඇතුළට යන එකට අපි plus දාලා තියෙනවා. port එකකින් එළියට එන එකට minus දාලා තියෙනවා. සාමාන්‍ය port එකකින් ඇතුළට දැන් මෙතනින් signal එකක් දුන්නොත් එහෙම මෙයා තමයි V2 minus එක reflected එක වෙන්නේ. හරි. දැන් ඇත්තටම V2 minus කියන්නේ මෙයාගෙන් එළියට එන signal. හරි. V2 minus is the මේ පැත්තට mark කරලා තියෙන signal එකනේ. wave එකනේ. හරි. So V2 minus is the output of this port and V2 is the input to the port. Okay. So this V2 is actually the reflected value. Correct? You have to understand that part. Okay. Now you want to make this reflected V2 plus. Actually, this is the actual reflected. Okay. Although we called it forward and this is reflected at this scenario, in this case, V2 plus is a reflected signal. That is what you should understand. Okay. So now you want to make this V2 plus to 0. So what you have to do? What you have to do? So V2 plus should be 0. That means the reflected should be 0. Then what you should do? The reflect to make reflected 0, you have to match this properly. Okay. So this input should be equal to the output impedance. Okay. So at that time you can match it. Okay. So that is how you match it. You can't, you no need to open or short circuit. Okay. You need, if you open this or short circuit, it not happen. Okay. So you should have to terminate this with the real. Okay. So you have to terminate this line with the correct impedance. Okay. Then there is no reflect. Okay. So the port is not we can't, if we open circuit or short circuit the port, this V2 plus will not be zero. Okay. But if we correctly terminate this line with the correct impedance, this V2 plus will be zero. හරි. ඒක තේරුණාද? මෙයා reflected එක V2 plus කියන්නේ reflected voltage. Reflected voltage එක බිඳුව කරන්න නම් ඔයා මේක open හරි short හරි කරලා හරියන්නේ නැහැ. හරි. කරන්න ඕන මේ ටර්මිනල් එකට හරියට ගැළපෙන load impedance එකක් match කරන එක. හරි. එහෙම වුණාම මේ ඔක්කොම ටික load එකට යනවා. හරි. මේ එන සිග්නල් එක V2 මේ පැත්තෙන් එන එක හැමම යනවා. ආයි රිෆ්ලෙක්ට් වෙන්නේ නැහැ. හරි. එතකොට ඔයා මෙතෙන්ට හරියටම සම්බන්ධ කරන්න ඕන ගැළපෙන load එකක්, match load එකක්. හරි. මේ match load එක සම්බන්ධ කරපුවාම සිග්නල් එක එතනින් එහාට එළියට යන්නේ නැහැ. කෙලින්ම මේක ඇතුළෙම එනවා. හරි. එතකොට V2 එක බිඳ වෙනවා. Okay. So what you have to understand, that is what you have to understand. Okay. So you have to terminate this with the correct impedance. Okay. Okay. Now think how we can calculate this impedance. Think about it. Take again 5 minutes and think about it. හරි. දැන් මේක තේරුම් නැත්නම් මගෙන් අහන්න. හරි. You can ask me if you can't, sorry, if you can't understand this, okay, then I will again. Okay, do you have any idea? So how we terminate this circuits? Can you see my screen? Wait. I think you can see my screen, no? Okay, so what we should do? Okay, now you can see that we need to make this V2 zero. Okay, then this side impedance should be matched to this line impedance, Z0. Okay, so you have to match this line impedance to the Z0. Okay, then the reflection will be zero. Okay, so there is no any reflection. Okay, so you have to match this end to 50. Okay, you have to match this end to 50. Okay, so you have to make this end also 50. Then you will, all the signals coming through this will go through the loads. Okay, so there is no any reflector value. Okay, so I will write the circuit here again. Okay, so this is my circuit. Here I have Z1. Here I have Z2. And here I have Z3. Correct? This is my circuit. Okay. Z1, Z2, Z3. Sorry. Okay. So this is Z2 and this is Z3. Okay. So Z1, Z2, Z3. Okay. Now, I want to match this end to Z0. Okay. So I have to match this end to Z0. Then the reflected signal you can make 0. The reflected signal is actually the input signal. So you have make it plus. Okay. So it is V2 plus. Okay. So if you terminate this end with Z0 load, what happened? There is no any reflection. Okay. All the signal will go through this load. Okay. So there is no any reflection. Okay. So now it is just like you are uh, you are connecting Z0 load to the terminal points. Okay, to the port. Okay. So now maybe you can find so you have to find S11, no? So S11 is equal to according to this equation, V1 minus divided by V1 plus. When this term is 0, V2 is 0, V2 plus is 0, no? V1 minus divided by V1 plus when V2 plus is equal to 0. So this is S11, no? So now I think you can calculate. Okay. So what is this V1? Okay. Now you are considering this port. Okay. Now you are considering this port. This port is terminated by Z0 load. Okay. So there is no any signal going out. All the signal will go through the load. You can assume that. Okay. So now you have V plus signal input and V plus minus out. Am I disconnected? Am I disconnect උනාද?
ඩිස්කනෙක්ට් වුණා සර්. ඒ චුට්ට ආයෙ පොඩ්ඩක් කියනවද? මේ ඇහුන්නේ කැඩි කැඩි වගේ ඇහුනේ.
right. ඊයෝ දැන් රෙකෝඩින් එක එතකොට දෙකකට එනවානේ. Okay. Okay, I will tell. Okay. So I have draw the circuit again here. Okay. So I will draw the circuit again. Okay. Okay. So S11, this is what we need to find. Okay. This is what we need to find if we want to find S11. Okay. So you can get it from this equation. Okay. So you can consider this equation and get this. Okay. When V2 is 0, this one is 0. S11 is equal to V1 minus divided by V1 plus. When it's V2 plus is equal to 0. Okay. So this is how we are going to estimate the S11 parameter. This is how we are going to estimate the S11 parameter. Correct? Okay. So if I draw the circuit again, here we have Z1. Here we have Z3. Here we have Z2. Okay. Like this. Okay. Now you have a input signal V1 plus and you have a reflected signal that is V2, V1 minus. This is the reflected signal V1 minus. Okay. So now you want to make this input signal V2 plus. Actually, that is the reflected signal to 0. Okay. For that one, you have to terminate this line with the Z0 load. Okay. Like this. Okay. Now you need to calculate this S11 parameter. Okay. So how to calculate that one? So what can you say about this? What is this actually? V1 minus V1 plus. This is the reflected signal divided by input signal. What is that one? You have another name for that one. I think you should be able, you should remember that one. Reflected signal divided by reflected signal divided by input signal. Actually, this is a voltage, you know. Reflected voltage is divided by input voltage. What is this equal to? This is equal to what? Reflected voltage input එකෙන් බෙදනවා මොකක්ද? අපි දැන් සර්කිට් එකකට යවනකොට impedance match නැත්නම් ඒක reflect වෙනවා. So you have a input signal and you have a reflected signal. මේකට අපි කියන forward signal එක සහ reflected signal. එතකොට මෙතන තියෙන්නේ V reflected බෙදීම V forward. මේ මොකක්ද? What is this? What is this? Yes, that is a reflection coefficient, reflection factor. Okay. Okay. So that is the reflection coefficient, no? Tau. That is the tau. Okay. So tau with here. That is the tau here. Okay. So so if you want to calculate the tau here, okay, so it is like this, okay, this direction, okay. So this is this direction, okay. So you can see that reflection is happen in this direction, okay. So tau is also in this direction, reflected direction, okay. So this is the tau you need to calculate that. So normally you have to mark like this, okay, this direction, okay, because reflection is happen in this direction. So your input is here, reflection is here. Is a reflection coefficient now. So it is normally marked like this as tau. Okay. Actually, this is the input reflection coefficients because this is the input port. Okay. So we can see it. We can name it as input reflected reflection coefficients. Tau in. Okay. Tau in. Okay. So if you want to, so using the impedance also, you can write an equation for this tau in. Okay. So you can write the equation for this tau in using the equation. Okay. So the terminal impedance is Z0. Okay. The terminal characteristic impedance are Z0. Transmission line characteristic impedance are Z0. Okay. And this tau in. Okay. Tau in is, you know that, okay, if you are measuring this direction, okay, this input, this impedance of this port, okay, impedance of this input port, okay. So still you can't, you don't know what is the impedance, okay. Let's say that it is Z in, okay. So input impedance in this direction Z in minus Z0 divided by Z in plus Z0. What is this Z in? The input impedance at this port, input port, okay. So the input impedance at this port, input impedance of this port, okay. This is input impedance. Okay. Z in minus Z0, Z in plus Z0 is the tau in, input reflection coefficients. Now you have to calculate this value, okay. So Z0 is given. Z0 is given. You need to find Z in, okay. What is the Z in actually? What is the input impedance means? That is the total impedance of this circuits, no? That is the total impedance of this circuits. So that is the input impedance, the total circuit of this circuits, okay? When we are looking this direction, okay? So if you are looking this direction, this impedance, not the total impedance, then you have to calculate it, okay? But for this side, okay, now we are looking at this side, okay? Now you want to calculate the input impedance here, okay? So you have to consider it from this direction here. You have to look at here. ඔයා මෙතනින් බලන්න ඕනේ. මෙතනින් පේන විදිහට ඔයාගේ impedance එක මොකක්ද? If you measure the impedance between these two terminals, what is the impedance? That is the total impedance of this circuit, no? Okay. So that is the ZD. Okay. So how to find the ZD? How to find the ZD? So you can see that here Z0, Z3 and Z0 is serially connected, and this one is parallelly connected. Okay. So here, this one you can write it as Z3 plus Z0. Okay. And that is one. Okay. One impedance, and another impedance is like this. That is Z2. Okay. So these are parallelly connected. Okay. So you can find the total impedance here. That is 1 over Z2 plus 1 over Z3 plus Z0. Okay. So if you get the common denominator, okay, and if you find the total Z here, that will be Z2, sorry, Z1, sorry, Z2, no, this is Z2, no, Z2, Z3, Z0 divided by Z2, Z3, Z0. Okay, so that is the total impedance here. And the total impedance of the circuit is, you should add Z1 also, no? So you can find the, so these are impedance. Okay, so you can find these are serially connected, and this one and this one parallelly, again this one and this one series. Okay, so you have to add Z1 with the total impedance of this one. The total impedance is of this one is Z2, Z3 plus Z0 divided by Z2 plus Z3 plus Z0. Okay. Z3, Z0 and Z3, Z0. Okay. So this is, okay. So this is the ZD. Okay. Now, if you want to find tau in, what you have to do? This one should be this term should, Z0 should be subtract from this term, and Z0 should be added to this term. Then you can get the division. So you can find the tau in. Tau in is equal to this one, V1 minus V1 plus, that is S11. Okay. So actually S11 is equal to tau in. That is equal to Z in minus Z0 divided by Z min plus Z0. Okay. So Z in you can calculate like this. Okay. So using this one and Z0, you can find the tau in. Okay. So this is it. Okay. This is how we have to calculate Z11 parameter. Okay. So try to understand it. Okay. Try to understand it. So let's say that we need to find S12. Okay. Now we will go to another one. We need to find S12. Okay. To find S12, what you have to do? To find S12, you have to, so now you need to find this one. Okay, S12. So you need to V1 plus 0. You need to do this V1 plus 0, and then you can calculate it as V1 minus V2 plus. Okay. So you can calculate S11. You can calculate S11, S12, okay, sorry, S12 as V1 minus divided by V2 plus, okay, when V1 minus is equal to 0, okay. Now you have to calculate this one, S12, okay. Okay, Now we will see. Okay, so you have to consider other way around. Okay, so you have to consider other way around. Now you are going to give the input here. Okay, now you are going to give the input here, and you need to make this V1 plus 0, that is the input signal here 0. No, the same manner. Okay, correct. Now you have the circuit. Okay, now I will write the circuit again. This is our circuit. Okay, the same way. Okay, same way. So now what you have to do, you have to make this V1 plus. Okay, so this is V1 plus 0. Okay, so this is, so input port to this voltage is V1 plus. The reflected voltage is V1 minus. Okay, so input to this voltage is V2 plus. Reflected to this port is V2 minus. Okay, now you have to find, V1 minus divided by V2 plus, and you have to make this V1 plus 0. Okay, then what you have to do? Okay, so you have to send the signal here in this side. Okay, so you can do it, no problem. Okay, so if this is output port, you haven't nothing to do. You have to send the signal from this side. Okay, so that is V2 plus. No, that is V2 plus. So that is the given signal for this direction. That is V2 plus. Okay, so this side we are making direction. Okay, and you know that, so this signal is going through, coming to here. Okay, and if this match is not, this load is not matched, what happened? Again, some portion is reflected here. Okay, so now reflected value should be V1 plus. No, it is the input, this side signal, input signal, that is V1 plus. So actually now this time it is a reflected signal, V1 plus. Okay, so now you want to make this V1 plus 0. Then you have to do what? Now I think you can give the answer. Now you have to, we have to do what? We need to make this V1 plus 0. That is the reflected signal in the port 1, no? When you are giving the signal in this direction. Actually, this is how we are going to measure. Okay, so in network analyzer also this same procedure is using. Okay, so if we want to make S12, what it is doing? It send a signal here, and it match the load here, and it measure the V1. Okay, output signal V1. So you have the input signal and output signal, then you can calculate. Okay, this is how the vector network analyzer calculate the S12. Okay, okay, so these things you should understand. Okay, now I think you should be able to give answer. To make V1 plus 0, what you have to do? V1 plus 0 means what? The reflected signal in this case. Okay, that is the input to port 1. So it should be the reflected one. Yes. So that is it. Okay. So we have to do that one. So what we have to do? Then you need to make this V1 0. Then you have to match this terminal to the Z node. No. If you match this terminal to the Z node, there are no any reflection. Okay. So now you have to match this terminal to Z node. Okay. You have to match this terminal to Z node. Okay. This terminal to Z node. Okay. Okay. You have to match this terminal to Z node. Now you will have, okay, you have to evaluate S12, that is V1 minus V2 plus. Okay, V2 plus. Okay, so if you have connect Z node here, what is the output? So that this V1 minus is the output voltage. Okay, V1 minus is the output voltage. Okay, so this is the output voltage. Okay, V1 minus. So you can find this using V2. Okay, using, maybe you have to use the what is called voltage dividing rule. No, this is V2. Okay, so you are applying V2 here. Okay, V2 plus, actually V2 plus here. Okay, now you have to calculate this voltage, that is V1 minus, no, the voltage going through this. Okay, so you have to calculate it. How to calculate it? So if I draw this again, okay, so we have V2 here. Okay, okay, and now, so you can see that here this terminal is not open nor short. Okay, it is connected to load. Okay, so current can be go through it. Okay, so if you write it again, okay, like this. Okay, it is like this. You have this one. This is Z2, no, Z3. This is Z1 and this is Z2. Okay, so you have Z3 here. Okay, and you have Z2 here. Now you have here Z1. Okay, you have Z1 here. Then you have Z0 here, like this. Okay, like this. Okay, and you are giving V2 here. You are giving V2 here. Okay, so now you want to find the voltage here. V2 plus. Okay, this is V2 plus and this is V1 minus, the voltage in this direction. Okay, output from the port 1, that is the output signal from the port 1. Okay, okay, so you have to calculate that part. How to calculate that part? So you can see that in this case you have to consider this this um, so I think you have to do it twice, no? Okay, like this, no? Okay, so you have to maybe you have to put voltage dividing rule maybe for 2 times. Am I right? So you can first write the voltage between this one and this one. No, using the voltage dividing rule. No, I'm not sure that, because some current is going through this, no? Okay. So how to calculate? So you need to calculate V1 with respect to V2 in the terms of V2. Then you can reduce this V2 values. Okay, so how to calculate it? Mm, think of it, and if you have any procedure, please tell me. You need to calculate this voltage. Okay, so this is a simple circuit. Okay, this is a simple circuit. You can consider Ohm's law and Kirchhoff law, and you can find. Okay, for a high frequency also, Kirchhoff voltage, Ohm's law are valid. So, okay, those basics law are valid for any frequency. Okay, but the value of the impedance may be changed. Okay, so that is happening. Okay, we can't say that these are not valid. Okay, so now you can apply the Kirchhoff voltage law or Ohm's law here. Okay, now you have to calculate this V1. So maybe we have to do twice. Okay, but you can't you can't apply because some current is flowing through this, no? Okay. Mm, so how we can calculate this? Mm, Yeah, using voltage divider, you can calculate, but the problem is that uh, because you can make you can put the voltage dividing rule here, okay, and you can find the voltage in this point, okay. So it will be definitely uh, let's say that this voltage is V, okay. Then you can put the voltage divider and you can find the voltage here. V is equal to V naught plus Z2 divided by Z3 plus Z2. Okay. So this is the voltage here. Okay. Then again, you can put the voltage divider to find V1 minus. Okay. To find V1 minus, that will be V Z0 Z1 plus Z0. No? So that is what you are telling. No? We can do this like this. Okay. Yeah. Okay. So that is the first method that's come to my mind also. Okay. But you can see that if you apply the voltage divider here, when you apply the voltage divider, this current should be flowing through this one also. Okay, this current and this current should be same. Okay, when we are applying the voltage dividing rule, let's say that it is V. Okay, and if you want to find the voltage here, so you are using Ohm's law. No, first you are putting Ohm's law for this one, that is V naught is equal to this. Let's say that this is R1, R2, R1 plus R2I. Okay. Then you are applying Ohm's law here. Okay. So let's say that the voltage is V. So V is equal to R2I. Okay. So you are going to divide this. Then I cancel. Okay. That means this I should be coming here. Okay. If this has a load, you can't put the voltage dividing rules at once. Okay. I think you can do like this, no? Maybe you can find, I'm not sure, okay? So you can find the total. Yeah, yeah, this way you can do, no? I think this way you can do, okay? So I hope this way you can do, okay? So this way you can do, maybe, okay? So this is Z3 and this is Z2, no? Okay. So if you want to find Z1 and Z0, okay. Okay. So this is voltage now. No, that is also not. So what I'm going to do is we can find the total resistance here, total impedance here, and you can find the total impedance here. Then you can put the voltage divider and is it equal to V1 minus? මම කියන එක තේරෙනවද? දැන් අපි මේකයි සමග ප්‍රතිරෝධය හොයනවා. ඊළඟට ඒ දෙකයි මේකයි සමග ප්‍රතිරෝධය හොයනවා. එහෙම කරලා voltage dividing rule එක දැම්මොත් එහෙම ඒක V1 ට සමාන වෙනවද? V1 minus ට. කාට හරි මතකද? එහෙම හොයන්න පුළුවන්ද? එහෙම නැත්නම් මෙහෙම හොයන්න බෑ මං හිතන්නේ නේ මේ විදිහට හොයන්න බෑ මොකද මේ පැත්තට කරන්ට් එකක් ගියොත් එහෙම voltage dividing rule එක දාන්න බෑ මොකද මේ I සමාන වෙන්න ඕනේ ඒක දාන්න. හරි? මේ පැත්තට කරන්ට් එකක් යනවා කියන්නේ මෙයා වැලිඩ් වෙන්නේ නැහැ මෙන්න මේ ඉක්වේෂන් එක වැලිඩ් නැහැ. හැබැයි අපි මේ අතර දෙක වෝල්ටේජ් එක හොයාගත්තොත් maybe you can do like this. Okay. Now, yeah. Okay. So can you understand what happened here? Okay. So I think the correct method is like this. Okay. So first it is like this. Okay. I will draw it in this direction. Okay. So maybe you can understand it very well. This is Z2, Z3, okay, sorry. This is Z3, Z2, okay. And here we have Z1 and Z0. Okay, it is like this. Okay. So now you want to calculate this voltage, that is V1 minus, okay, in this direction. And this voltage you can given V2 plus, okay. That is the voltage given to this port 2. And this is the voltage going out from the port 1, okay. So you have to calculate this V1 using this V2, correct? Okay. Now you have to calculate this one, okay. So now you have to apply the voltage dividing rule, okay, voltage dividing rule, okay. So first you have to find the voltage here, the voltage between this terminal and this terminal, okay. So how to find that? Okay, so you can't directly apply the voltage dividing rule, because when the current is going through this, another current is going through this, and another current is going through this, okay. So this is not the same current. So this is at 3 and is at not, okay. So these equations are not valid, okay. These equations are not valid, correct? Basic electronics, okay. So now you have to find the resultant impedance of this terminal, okay, between this one. So how to find that one? So that is Z1 plus Z0, okay. So that is the total impedance here, and Z0, okay. So now you want to find the total impedance in this terminal, okay. Let's say that this is Z, okay. So here the Z is equal to 1 over Z is equal to 1 over Z2 plus this one and this one, 1 over Z0 plus Z1, okay. So you can find the total impedance Z as Z2, Z0 plus Z1 divided by Z1 plus Z0 plus Z2, correct? So this is the total impedance, this, okay. Now that this current is going through this total impedance, correct? This I is going through this total impedance. So you can calculate the voltage between this terminal. Let's say that that is V. V is equal to nothing but